Okay, the first thing that we're going to look at, if you have the note guide, the first thing in the note guide is this little chart up at the top. It's just a place for you to kind of summarize some notes about the basic forms of quadratics. So we're going to study quadratics, but we're going to make sure that we understand that the equation can be written in different forms and that each of those forms have some information to offer us. So there's nothing really specific I'm asking you to write down here. If you have the note guide, it just kind of says like what's the format of the equation and what are important notes that you have. We are going to study each of these things individually and learn every aspect of them. But the goal here is just for you to remember the structure of a parabola and when it's easy to get certain information. Okay, so our quadratic is the parabola, and it looks like this. Sorry, I'm trying to make this a little bit bigger, but we'll just go like this. Does really not work well. All right, so here's our parabola. Nope. Okay, important parts of the parabola that you should know. These points on the parabola where it's crossing the x-axis actually have multiple names. So graphically, because they're crossing the x-axis, we say x-intercepts. Is that okay with everybody? Does that make sense? Okay. They're also referred to as the roots, zeros, or solutions of the equation. When you guys solve a quadratic, you set the quadratic equal to 0, right? Which means what are you putting equal to 0, the x or the y, if you're setting it equal to 0? The y, and when the y is 0, the values you get for x would be plotted on the x-axis, which again would make them x-intercepts. So anytime you hear a question, and whether it asks you to find x-intercepts, roots, zeros, or solutions, those kind of all mean the same thing. It can just be said lots of different ways. In all of those aspects, you're solving or you're looking for the place where the parabola crosses the x-axis. Is that okay with everybody? Okay. And this is an important part of the parabola, but is not always easy to get graphically. This is why you learned like quadratic formula and all these other things, because these are sometimes difficult to solve for, okay? All right, another important part of the parabola, axis of symmetry. We need to kind of know where everything is centered in our quadratic. So the axis of symmetry kind of gives us that location. And then lastly, very slowly, sorry, is our vertex point, okay? So our vertex has to line up, right, with the axis of symmetry, okay? Otherwise, our parabola wouldn't make sense, right? How can it be symmetrical around this line, but the vertex is the exact spot where it turns around? They have to line up. So these are kind of the things we're going to focus on, that we want to know the vertex and axis of symmetry of our parabola. To graph, we need some other points besides those. Not always these points. Sometimes these points are so hard to find. Or let's say you do find them with the quadratic formula and the answer is like 1 plus or minus rad 2 over 5. Like, do you know where to graph that point? Like, I could approximate it, but it's not something that's like, oh, it goes right there. Like, no, okay? So those aren't always the nice points to find. Sometimes it's easier to just plug something in and get some other points. But if you're graphing, you need axis of symmetry and vertex and some other points. Sometimes it's nice to have these ones, sometimes not. But even if we're not graphing these solutions or x-intercepts, we need to be really good at finding them because they mean a lot for the parabola, okay? All right, how you may have seen the parabola equation written most of the time. Your quadratic equation is in standard form. So standard form for the quadratic is ax squared plus bx plus c. This is every time you use something like the quadratic formula and they have a's, b's, and c's in it, they're referring to the coefficients in this standard form, right? So we use this a lot. If all the formulas have a's, b's, and c's, then they're expecting us to be able to write the equation this way. If we're going to graph the parabola from this form, okay, it is not easy to immediately know the solutions. To solve this, I'd have to either try to factor or find the quadratic formula. It might not even cross the x-axis, right? So finding the solutions is not simple here. They're there and they exist, but not simple. So since we don't know if this is factorable or not, and we're just being kind of general about it, I've just put the quadratic formula here, like one way to find the places where it intersects is quadratic formula. We have to know that. Is that always what I'm going to want to find when graphing specifically? No, we just talked about that. That could be difficult, but we should know that that's what the quadratic formula is finding if I do use it. It's finding these x-intercepts or the solutions to this equation. Okay? So the other things we focused on were axis of symmetry and vertex. Can somebody explain to me where the axis of symmetry is in this picture compared to the two solutions that we just found? So what's the relationship between the location of the axis of symmetry and these two solutions? Cooper?
It's right in the middle of them, like in the exact center.
Good. It's right in the middle of them, in the exact center, right? Are you guys okay with the language he used? That makes sense? So when you guys are looking for something that's right in the middle of something else, let's say I gave you the numbers 5 and 8, and I wanted to know which number is right in the middle of them, what operations would you do with 5 and 8? Ethan? You would add them together and divide it by 2. Your average finds kind of the center of them, right? So the average here will give us our axis of symmetry is going to be this negative b over 2a. So this is what makes math super amazing, is that these formulas, I don't know if you guys feel like I did in Algebra 1. I felt like someone just made some stuff up, and then we worked stuff out over there. No, because of the half, the average. When we added it together, it's negative b over a, but then we had to divide it by 2 for the average. So math has like all these things that you think are just separate formulas that somebody made up. They actually all come from like one thing. They just probably got sick of doing it all the time, so they generalized it into a formula so that you didn't have to redo all the operations that they do all the time, right? So how is the vertex now related to this axis of symmetry? So you have this axis of symmetry. If you know that the number that is in the equation for the axis of symmetry can be found by negative b over 2a, what does that tell you about the coordinates of your vertex down here? Mary? It has to have the same x coordinate as the axis of symmetry. Is that okay with everybody? Okay, so, oops, very slowly, here it comes, okay? It's going to have the same x coordinate as whatever I calculated for my axis of symmetry. And then do you guys understand this notation for the y coordinate? What am I saying when I write f of negative b over 2a? How am I saying you would actually find the y coordinate of the vertex? So the x coordinate would be from this calculation. How would you find the y coordinate? I see Cooper. I'm just making him wait because he's told you guys a lot today. What does this notation mean that I'm telling you to do? James? Good. Okay, and I don't actually want you to go plug in negative b over 2a and write that out. What I would want you to do is find the number that you get from doing negative b over 2a, and then I'm just trying to make a note to you that that number should match this number, and that you always just find a y coordinate by plugging the x coordinate into the function. Is that okay with everybody? I know the notation's a little bit funny, but that's the idea. All right, so if we start with an equation that looks like that, we actually are usually going to start by finding the axis of symmetry, because this formula is a lot simpler. We can find the middle of our parabola, and then using that information, we can find the vertex. And then if it's easy to solve, maybe the solutions will be what we plot on the side. If it's not easy to solve, we're just going to pick one of the things that are to the side of the axis of symmetry and just plug it into the equation to get another point on the graph. Okay. And again, you guys are going to learn all these separately, so we're just letting the parts sink in. We just want to see relationships right now. That's just kind of our goal. Okay. All right, sometimes your equation can be factored right away, and you can factor it, and they give that a name. It's factored or intercept form. Okay. Does anybody know why the factored form would also be called intercept form? Why would they name it that? Taylor?
Because you can solve the x-intercepts directly.
Yeah. So all I'm doing here is reminding you guys that you know stuff. If someone's already giving you the factors, think about why you use factoring. You use factoring to get solutions, right? What are solutions on the graph? What piece of the graph are they? X-intercepts. So in this case, probably the fastest thing to do is to quickly find your x-intercepts. Again, I know the notation is super weird. I'm just using a P and a Q because I'm just basically saying they're coming from those factors that are there. Okay? If you can quickly get the x-intercepts, how did we just figure out the axis of symmetry with relation to the x-intercepts? What did we say you could do to find the axis of symmetry if you had the x-intercepts? Katie? Yeah, and then here, P's and Q's aren't really important to us, but I don't know how else to write it without numbers, right? So whatever those numbers are that you came up with where you know it's crossing the x-axis, you're going to add them together and divide by 2. Okay? And then how would you then get your vertex? What do we know about the vertex right now if we've found the axis of symmetry? Same x-coordinate, and then how do you find the y-coordinate? You plug it in. And again, the notation's going to look weird, right? We're getting used to this mathematical notation, but here it comes very slowly yet again. So whatever the x value is from your axis of symmetry matches the x-coordinate for your vertex, and the super weird notation for y, I'm not really asking you to do anything super weird. I'm just saying whatever number you got for x, can you please go plug it back into the function to get the y-coordinate that goes with it, okay? And again, I don't want you to memorize all this stuff. I want you to see connections. So if I lay something in front of you and it's already factored, I want you to have that light bulb in your head that are like, factors are solutions very quickly, and solutions are x-intercepts of a graph. And I know how an axis of symmetry is related to the x-intercepts. I know it's in the middle, and I can work out how to figure that out. That's all I want you to see. I don't want you to memorize a bunch of steps. I want you to be comfortable with relationships, okay? All right, the last format we're going to look at is vertex form. So if we would have started our class with quadratics, if this is the unit we would have started with, and I showed you the ax squared plus bx plus c, I'd feel pretty confident that you guys had all seen that before. Knowing what Algebra 1 teaches now, I feel fairly confident you've all seen this before, but this should now have totally different meaning to you after our first unit than it did in Algebra 1, right? What do a's do? Things that are in this position. When we have an equation written in this format, what does A do? We talked about it yesterday. Valerie? Good. Okay, so with lines we said determine slope. Now we're going to use slightly different language, right? Because a parabola doesn't technically have a slope. It does what? James? Yes, rate of change, but then it's still not consistent. Taylor? Good. A type of vertical stretching or compressing, okay? So before in Algebra 1, you might have seen it get narrow or wider, but now we want to use those words vertical stretch and compression. And what are our h and our k going to do to the parabola? Cooper?
They determine the vertex.
Yeah, they're going to determine the vertex. They're going to shift it left and right and start it at a new place separate from the parent function. So what's probably the easiest thing if you had to graph something in this form? What could you pick out first that would give you something immediate that you could graph? Ethan? You can't see numbers in this one, so you can't pull out specific numbers. But which part of the parabola could you kind of know immediately from the way the equation's written? Andrew? Good, the vertex. It's written in vertex form. The h and k do the shifting. So this time, nice and slowly, but not the last thing up here, we could immediately just have our vertex. Okay? Which means what else do we know if we know the location of our vertex? Good, we know the axis of symmetry. Okay? And then here's where it gets a little tricky. If it's easy to solve, then I'll go find the solutions. But do I have to find the solutions to get a good picture of the parabola on the graph? No, I need the vertex. I need the axis of symmetry. Other than that, I just need some points on the side. So it just depends on what your purpose is. If my purpose is just to graph, I don't have to make sure I have the x-intercepts. If my purpose is to solve or know some very specific things about this quadratic, I probably have to do some algebra and get to know the x-intercepts. Okay? Is this okay with everybody? All right, so again, overview, but do you now know the pieces of parabola, what we're looking for, that sometimes when we're graphing, the solutions are great. Sometimes if we're just graphing, we don't really care what the solutions are, but eventually we're going to care because solving a quadratic helps us figure out a lot of different types of problems, okay? Is this all right for a general overview of all the ways graphing the same thing but from different perspectives, okay?